Hi everyone. So my name is Sandesh, and I'll be going into deep dive into the key points which are involved in migration from relational to NoSQL databases. And so let's get started. So the first thing is it is very important to know the major difference between SQL and NoSQL databases. So it's not just like many people are following. That's why we have to do it. You need to know the major difference. There's The difference is how they are built, what type of information they store, and how they store it. So in the diagram, if you see on the left side, we have a SQL database which stores data in the table and records form. On the right hand side, we have a diagram which shows a MongoDB database, which is showing a document storing some information. This diagram is about comments, blogs, and posts. So the major difference is how they are storing that information and how they are built. So that is the major difference, and we'll get into deep in the next few slides. So choosing relational versus NoSQL databases. So what are the key factors that we need to go over to choose between whether we should go for relational or NoSQL databases? Because the one thing we need to understand is NoSQL is not the replacement for relational databases. It has, of course, many more features and it has different designs and everything, but it's not a replacement. There are still many organizations and many scope that requires to go for the relational databases. So we'll just go over through in brief. So reasons to choose a SQL database. So like I said, many organizations still rely on relational databases. And so the major reason to go for a relational database is ACID compliancy. So atomicity, consistency, isolation, and durability. These ACID properties make sure that your database is robust enough to handle any anomalies and your data integrity is properly handled. So this ACID compliancy makes sure that the flexibility, the processing speed, and many more things related to your entire application and your business model are followed properly. Because if a database transaction fails, it needs to roll back and do the proper changes back the way it was. In that case, relational databases plays a major role. And the other reason is your data is structured and it is unchanging. If you know for your application or for your organization that data structure is going to remain the same, especially this is the case for small organizations and some of the organizations who has projects, they are fixed design. The data is not changing. In that case, relational comes very handy. So reasons to choose NoSQL databases. So everyone knows that nowadays everyone wants to use NoSQL database, but what are the main reasons to go for that? So first thing is we can store large volume of data. Even if it has structure or very less structure, it has no structure, it is still a very good approach to go with NoSQL database if you're storing large volume of data and your data has no structure. So in that is the major point for choosing NoSQL database. And the second thing is so we have a lot of cloud storage available for NoSQL databases, which makes it very cost effective and it's very effective to make a rapid development. So in case of NoSQL, you need to know in the beginning itself what is going to be your database design, what is going to be your model, what is going to be your entity relation diagram. Everything you need to know in the beginning so that you can design your proper database properly in the first phase itself. But on the other hand, in NoSQL database, you don't need to know all those things in the first step itself. You can, as long while you're making your development or the way you're progressing to completion of your application, you can still make changes to that once you have new requirement. So in that case, it helps a lot. It makes your development very fast and it makes any change possible very quickly. So that's some of the reasons we need to go for NoSQL databases. So these are some of the SQL databases I have noted down here. So MySQL is the very famous one, everyone knows about it. So we have Oracle, IBM DB2, Sybase, MySQL Server, Microsoft Azure, MariaDB, PostgreSQL. So some of these SQL servers or databases, they are now also supporting NoSQL features as well. So the application providers have made improvement to that, but these are the major ones which are basically used in relational databases. So we also have here PostgreSQL. So some of the organizations still go with PostgreSQL because it is very efficient when you are developing something with Python or Perl. It has very good libraries which you can make use of to make your development fast and efficient and even get the better results. So there are some of the key factors that people still, organizations still choose PostgreSQL, especially when they're using it through Python language. So some of the NoSQL databases here. So MongoDB is the most famous one for now, at least now. We have other Apache CouchDB, HBase, Oracle NoSQL, Cassandra, and React. So we'll talk more about MongoDB because it's very common. So just to give you a brief about HBase. So many projects which involve big data and a really large volume of data needs to go, they usually choose databases which can handle big data, big table, HBase, and such other DB. So we also have Cassandra, which is a wide column store database, which is nowadays getting very good attraction, and it is very efficient when we consider NoSQL databases. Many of the social media companies are using Cassandra database to make their applications very robust, and data is keep on changing and new things coming up and everything. So Cassandra can handle a lot of changes, and it is very efficient to handle big data, that is really large volume of data. Okay, so now we'll get into a little bit of technical details. So we'll be talking more about MongoDB because it is more commonly used. And so what we need to consider when we are migrating something from SQL to NoSQL. So we have identified overall differences, but what are the technical differences we need to think about when we are migrating something from SQL to NoSQL? So we have tables in RDBMS, whereas we have collections in MongoDB. A row is now a document in MongoDB, a column is a field. So basically in MongoDB, we have all of the things in the form of JSON. So if you see in the data mapping diagram, we have a few of the records on the SQL and how they are stored in the MongoDB. So it's a JSON format, and we have kind of key value pair really in that JSON document, and that is how it is stored. We have a city and city name. That's how it stores in the document. Okay, so what are the key points that we need to consider before starting migration, or if we want to go with migration, go ahead with migration or not? So first of all, we can create a module or tool which exports SQL data straight into MongoDB. But it is not as simple as it sounds. It is a good approach because it is more controlled, and you can have more control over it because which data you want to do transfer, export, to say it properly, and how you want to export it. But it can become very tricky as SQL data is normalized and Mongo deals with denormalized data. So that is one of the major factors that any DB architect should consider while migrating. Other option is to make use of readily available tools. So we have a MongoView tool which provides a feature to import data from SQL to Mongo. But here again, same question comes, that is the straight import efficient? As far as I have experienced, straight import can make DB design complex, because how SQL databases are designed and how Mongo databases are designed, it's totally different. So straight import can make things complex in future. So some of the steps which are involved to make this transition simpler is, first we need to decide that what design we need in our new database. What all documents, objects, and all those things which are in SQL, do we want those, or in the new design what extra features do we want? So that design has to be ready in the beginning. So for example, we have just to consider one entity, we have an employee object. So in that employee object, what all fields are required? We need to think about that. In the second step, what we need to do is in SQL we will have multiple data tables, I would say, that employee table, employee info, employee type, and so on and so forth. We'll have multiple tables because we have normalized those tables, and whenever we need something, we just write a good query to get all those information, combine it, and pass it to the application, or display it whenever user requests it. But when it comes to MongoDB, we need to combine all those tables in a one fully realized employee object or document that can store, so that we can export as it is in MongoDB. That will help us, decrease the complexity. This second step is very important because instead of having 10 employee tables, we will have only one table with a lot of more information, and we don't have to worry about getting it redundant or anything, or getting data size huge, because NoSQL databases are very good with handling large data sizes, and it is also efficient. So that while migrating, we need to consider about the second point, that combining tables. So now we come to third point, that which we already discussed, that we need to have a module or tool which can be used to import data from SQL to NoSQL, and we will be making this serialized way. So all the data which we have got from SQL, those we will be storing in form of JSON, and it's very easy to write any JSON data into the MongoDB, and this will be done with the data migration. But there are some other some of the things which we need to consider, such as some of the technical points which we need to consider during migration. That we talked about migration data. Now, what about the query update? What about the aggregation operators? And what about the store procedures? So in SQL, we have seen stored procedures and join queries, aggregation operators like count, sum, order by, and all those things. They have made our RDBMS life so easy. But what changes we need to make it work in MongoDB? So this is just a sample SQL data. If we already have a data in the database, we just need to migrate it. But here I have put the example just to show that how we create or connect to database, create table, and insert into it. So in the first step, we have just created a connection to the database. In the second step, we have created a table. In the third step, we have inserted some record into the table. And in the fourth, we are reading that data from our relational databases. So here we can see we have made all those fields, tables, columns, and everything is properly designed. When we are reading that data, we are simply fetching it from the database, and now we have the data and we need to migrate it into MongoDB. So what we need to do with the result set which we have got back from the SQL. So once we have that data, we can simply convert it into JSON, and to put it in so we in the MongoDB, every row we need to convert it to in the form of BSON, which is binary JSON, which is the format that MongoDB accepts. So when we have that JSON, we need to convert it into proper format and insert into the database. So while doing that, there are some of the steps that we need to follow. If we have already designed and created a MongoDB collection, that's good, or this is just a sample on how we can do it. So in step 1, we are creating a MongoDB collection. There are some of the libraries very helpful, making this simpler. We are creating a Mongo connection, and we will be adding our data which we just retrieved from SQL in this collection. So whatever data we had retrieved from the SQL, we will be converting into form of JSON. So once we have that JSON object, we can add it into the MongoDB as it is. By the way, it accepts the BSON format, which is a binary JSON, and we need to convert it. We have a simple function call we need to make to do that. Okay, so once we have that BSON object, we can simply add it as adding a new new element in that document in the MongoDB collection. So now we can add as many records as we want. So here we are adding a new record which we can take from SQL, or if you have a newly coming data, you can add it directly over here. You can display it and everything. So these are the very simple, steps how we can retrieve from the SQL, and how we can uh, export it to a MongoDB database. And we need to close the connections once we do that. So now we will talk about aggregation operators. So in SQL, we have used where, group by, select, sum, count, and join these aggregation operators so many times, and it had made our life so much easy to make write or good efficient queries. But in MongoDB, we do have those features available. It's just the terminology changes and the way we use it that is changed. But one important thing we'll talk about joins in the next slides, that which is efficient and how it works. But for other aggregation operators, it's almost as the same. It's working as same as how it was working in SQL. It's just the way of usage is changed. So here we have one aggregation example. So on the left side we have a SQL query. What that query is doing is it is counting the distinct number of customer IDs and order date. Once we group that, what is the total count of that? So that is the result of that query we will get. So in the left side we have the SQL query, whereas on the right side we have the same transformed query, which is compatible with Mongo database. So you can see in SQL, it looks very easy how we can write a query, and in Mongo it just becomes so much lengthy. But once you get hang of it, it's very easy to play with JSON. It's all JSON playing with JSON objects, key value pairs, and functions which are available. So to make use of these aggregation operators, we need to call db.tablename.aggregate function and pass this JSON as a part of query. So you can see that we are using a $group sign, which is aggregation or same as group by. We also have a sum, $sum, which is same as count in the SQL. So this is just a sample to show how a query looks in Mongo, how query looks in SQL. But this is even if it looks complicated, once you get used to it, it will be very easy to use it, unless you have a very complicated queries where you are using join and some other inner or sub queries in SQL. So I have a next slide for that. So in SQL, join is very efficient and it's very easy to use, whereas we have lookup on MongoDB to get the similar functionality what join is providing. But when we are converting any queries which are using join, in, or any nested subqueries into a Mongo query, it becomes very tricky. It can get really ugly, or really what I would say is really complex when you have a really complex query in SQL. So this is the reason, if you remember on the previous slide, on the second point, means my suggestion was to combine the tables which are of the same type. For employee, if you have multiple tables, combine it to one, which will make our life easier when we are writing queries. Because if you see here, I can have multiple joins, multiple subqueries if my tables are I have like 10 tables related to employee. But on the other hand, if I have only one collection which is related to employee, my query will become very simple. But if you don't do that, and if you migrate data directly, in that case your join queries will become very, very complex when you're converting to Mongo. So this is just a sample how we are using in keyword and subqueries using the lookup. So on the right hand side we have database.tablename.aggregate function again, then lookup, then from we have inventory. So here inventory is the table name, second table name, and orders is the first table name. Then the local field which we want to find, the foreign field which we want to find, and how we want to show that result. So that's what this query is about. Okay, so in SQL we have stored procedures and functions which makes our backend transactions very easy. So we have something called store.js in Mongo to make that same functionality available. So here, if you see, I have a JSON object which has a function name, then the details of the function, what parameters it is accepting. So it is going to behave same as how it used to behave in stored procedures. So so here if you see underscore ID before that, so I will have my function names. My function name is sum. What is the value for that function? That means what is the definition of it? Function xy, and it returns x plus y. So this is very simple example which returns the addition of the two numbers. So to transform all the procedures of function, to make it same behavior in Mongo, we need to convert into store.js, and we can call those functions using the name which we have assigned in that JSON format of the function. So we have all this store.js available from system.js collection, so that we can make use of and create as many store.js as we want. Okay, so what are the challenges that any DB architect or any developer will face while migrating those? So for first thing, like what I said, join queries, complex join queries in SQL can get really complex in Mongo or any NoSQL database. So we need to be very careful that we are doing enough pre-processing or I would say pre-migration work to make sure that these queries will not be a problem in future. Other thing is MongoDB doesn't automatically treat any operation as a transaction. So in SQL, it is very easy for us to identify whether transaction is complete or not. If it is not transaction, I mean any database operations, insert, update, retrieve, or whatever. So if that update transaction is complete or not, if not, something goes wrong, then roll back it to the previous stage. In SQL, it's very easy and it stays that way. Whereas in MongoDB, it doesn't treat these operations as a transaction. So we need to manually make sure that the transaction is getting completed successfully. If it is not, then we need to roll back it and commit whatever the change, whether it's successful or not. So to put it simply, some of the operations might succeed, some of the operations might not. So we need to make sure that add extra checkpoints through code to make sure that all the transactions are getting successful. And if not, we need to have a rollback plan for that query. So these are the major two challenges which any developer must think about before moving forward. There are other challenges, but those are not big ones, so that can be handled during development phase itself. So let's talk about scalability, rapid development, and cost efficiency. So in relational databases, so the big difference here is relational databases, they grow vertically. If I want to add something, add more processing power, let's say my current DB server is very slow. If I want to add something, I want to increase the power, I need to add extra hardware and make sure that it's processing with a good speed. On the other hand, NoSQL databases, my database grows horizontally, which means I can simply add another machine, which will definitely load balance the load of the data coming in from the application, and it saves time. We don't need to do anything to scale it up. We just need to manage the machine. That's it. We need to add, because the database is growing horizontally. That is one of the very big advantages considering NoSQL database or non-relational databases. And considering maintenance, so SQL and relational databases are expensive and complex to maintain. We need a proper cleanup activity and all those things, and it is expensive to manage these machines which you have used for database transactions. On the other hand, managing a cloud-based service, which is we are using for any non-relational database, it's very cost-effective and simple. And integrated caching. So for if I want to use any caching mechanism in my database, I'll have to use a third-party infrastructure, so it does not provide me the caching capability. But on the other hand, I will have a caching mechanism available internally itself, or I can make use of third party as well, but I have that feature to use the internal caching. So caching helps a lot when you are retrieving some results from database and you want to keep it for a while and then use it again, so that you don't have to run queries again and again and again. You can store it, cache it, and then make use of it and perform your activities in the application. So for example, Redis is a very good caching mechanism, if you guys already know. So, but the major point is non-relational databases have this caching mechanism internally built, and that makes it easy to make it efficient. So some of the use cases and results. So I will be showing you our recent project which we did for our one of the client. What are the results we got from that, and what was the architecture, and what was the architecture in the old system and the new system. So this is the very basic overview of the architecture, where we have users, application server, APIs, and the database. So we will focus more on the database because that's what this webinar is about. So here in the old application, we were using SQL Server, and the application functionality was majorly dependent on the searching functionality. There were like many types of searches, and companies were using that to find very close enough or exact search data so that they can use it in further their reports or whatever their business model was. So the limitations of this system was the data load was needing like more than 16 hours. So how that application was built, the data load happens is a full data load. It wasn't a data load, so it was a full data load. So every time we have to log the database, we had to load data completely. It was taking more than 16 hours to load that data because it was a full load. And during that load activity, application was down for more than 2 days, because after that we had to do definitely a stress test or whatever the test cases we have used previously. That time is not included here. That will be more than 2 days. So this database had 180 million records, which it was search. So the application was searching amongst those results. So it was a very old project, and the architecture design, it was not very efficient. So these were the limitations. Some of the searches were getting timed out. Some of the searches were giving results in 1 to 3 minutes, where it should not take that much time. And also client wanted a type ahead functionality, which they could not get it in that application because search itself is very slow. So I'll be showing the new proposed architecture. It will be simple. It will not be a complex architecture. I'll be just showing what part we changed. Instead of using MySQL databases, we use Elasticsearch and a NoSQL database, which was Cassandra, in this application. So this changing database from SQL to NoSQL and using Elasticsearch made the application architecture very robust, and the data load time, it was dropped by 80%, and the application downtime reduced to 2 hours, because loading data into Cassandra and then using Elasticsearch, it is very fast compared to SQL. And here we have the two options of, if we need another clone server to make the application downtime for zero application downtime. Basically, if you have the budget and the right project design, you can bring the application downtime to 0 when data load is happening, and you just need to switch between the old and the new ones where you have loaded the data. So, but here the project was not, that scope was not there in this project, so we use the same database, but the application downtime reduced significantly. Search results became more than 8 times faster, and the queries which were getting timed out in SQL, they were giving results in less than 3 seconds. Sorting and filter record in less than 2 seconds. And it is very easy to add the type ahead feature that was still not added, but with the help of all this efficiency, we can definitely add this very easily. Whereas on the SQL side, we need to think about twice to make that change. So this is the result for 2500 record count. So if you see on the red, we have MySQL results. On the blue, we have Elasticsearch without cache. And in orange, we have Elasticsearch with cache. So for caching here, we used Redis, which was very helpful when we are searching. And if you want to just reload the data, I don't need to go back to server and query it again. I have the data already over there. So we have three types of searches in this application. Starts with, contains, and exact match. So if you can see, in Elasticsearch with cache, we were getting results in 0.009 seconds for this 2500 record count. And on the other hand, if you see the SQL, it was taking 10 seconds with starts with. And the other two types of searches, they were not giving result at all in SQL. They were getting timed out. You can literally go have lunch and then come back, still result is not there. But that changed when we switched to NoSQL and Elasticsearch. So this is the result for 5000 record count. So it is taking a little bit more time, but that is significantly less compared to what SQL was giving. It's still in seconds, like I would say fractions of seconds. So this is the complete result for 180 million record count. So this is the result that we were getting searches, any type of search that keyword is starting with, it contains that keyword, exact match in entire database with having 180 million records. We were able to achieve this successful result. And the results were like, means you can see from timeout, we have brought it to 1 second or 0.5 seconds. That is very efficient to display any result on the application. So I'll just talk about RC expertise, how RC can help you in your migration projects, or in your, even if it's not a migration, how RDB architects can help you to make a new application with all new technologies, including all NoSQL databases, Elasticsearch, caching, and all those things, end to end, even the front end part. So let's talk about what RC can solve, like how many problems RC can solve for any organization. So the problem for some of the databases is, we'll just see, anyone knows that good database is very critical to implementing a project successfully. And nowadays data is growing with exponential rate, and that makes it very difficult to manage that data and keep up with the speed, performance, and expectation of the industry. So that problem RC expertise can definitely solve. We have DB architects, so many DB architects who are expert in NoSQL and even in SQL. So it's very easy for them to have this design ready and everything. So other thing is, what is less clear here is how the transition occurs from legacy RDBMS to modern NoSQL. We have seen in technical details that how it can be migrated, what steps are needed, and everything. But when we are actually doing it, that time we will know what are the challenges. So, and we have done it so many projects based on those that RC can do it very quickly and efficiently. RC has done many assessments over the past year for organizations, and we can also do the same for your organization as well. If you need to migrate it to NoSQL databases, so it can be which database and much more. So migration is not as straightforward as using NoSQL system in any new system. So that is one thing. Any successful migrating from relational to NoSQL requires careful planning and design. Poor data model and design will create problems in future, and RC expertise can solve all of these problems for you. And that's all. So thanks everyone.